Hey everyone, big hello to you all. Today we're doing a quick review of the JPT-20LP machine. This machine is specifically designed for, well, in this case at least, for keyboards. We have the standard housing, standard collimator head, tripod stand, and work table. The work table width is 35 and the total length is 55 centimeters. Today we're using the f420 lens at its maximum height with a 300 by 300 working field. We'll have two marks here now. One mark is from the 100 by 100 lens. We did a preliminary test earlier. Right now, we basically have clients here looking to buy this equipment for keyboard use. Again, as practice shows, it handles it quite well. The only question is the keyboards themselves, whether they're suitable or not. Let's take a quick look at the technical documentation and what you should pay attention to with these machines. It's the LP series, letter E-20, LP series meaning MOPA with a fixed pulse type, S series without a built-in tracer beam, so no built-in tracer module, or as they also say, a built-in bullet. Next, 25 kHz is the nominal frequency range at 200 nanoseconds, which is also that fixed pulse type, so we're taking these factors into account here as well. Everything else is within specs, so 1064 nanometers, a deviation of plus or minus 9, well, roughly up to 9 to 12 nanoseconds duration, specifically the duration, meaning the frequency, the repeatability of the frequency range. I'm getting a bit tongue-tied. The frequency range it can operate in or be tested at is from 1 to 600 kHz, with power adjustment from 0 to 100%. Don't forget about the nominal frequency range. We mostly use that and above, we don't work below it. The PDF technical docs usually state that with this equipment, when working at the nominal frequency range and above, you can run it 100% power or more. Today we'll do a simple basic test on this keyboard here. It's a MacBook keyboard. An important factor we're going to consider here is the distance from the keys. You can see there's an F on the enter key, and we have an F on the shift key. The distance between the Fs is 27 centimeters. So we could even set it a bit larger now and reduce the detail accordingly. The keyboard isn't small. Small keyboards are 24 or 22 centimeters or 220 millimeters. The smallest I've seen for field engraving was around 19 to 18 centimeters. Again, for keyboards, the average value for most of you to understand is what we engrave on the Yo key. At least here, we tested the Yo, the slash, and the Yo key in the top corner. It's mostly calculated from the Yo key. Well, if we're talking about fields, the maximum value used here will be 22.5 or even 22 centimeters max in our case. What we measured by the F keys is to understand the maximum effective range of this lens for key engraving. Now let's take a quick look at the parameters and characteristics we're setting here. 3 parameters, field settings 300 by 300, so the working field dimensions, offsets, leaser control 20 to 600, we set up the power map as it should be. Here we turn on enable pulse width or width, the pedal connection port, others we set the dimensions, again for the speed modes, red beam setup, timings for all, the machine's operating ratios. So basically, the red beam offset dimensions and its size relative to the working field. Got it. Seems clear enough. On the right side, in this case, I didn't bother setting up Start TC since I'm not interested in that. Let's run a little test too. For instance, we'll enter a value. Well, let's make it a bit smaller. Let's just write Igor. Value 1, the height, well, usually 3 millimeters is standard. We don't need to make it any bigger. Center. Drag it from the center toward the letter F, Control C, Control V, then center it again and drag it to the left side, also toward the letter F. Select both objects, go to hatch. In the hatch settings, we set the line spacing to 0.04 millimeters, bidirectional, continuous, auto rotate 25 or 45 degrees if you like. Check hatch one by one, meaning fill them one after another, so we can fill them independently and test them during engraving. I set the speed to 2000 here, power at 20%, frequency 25 kHz, start TC, laser off, NTC, polygon TC. I didn't set those. Don't see the point, because we're using a bidirectional spiral here, which is continuous. And this is where polygon TC plays a big role. In advance, I reset the jump speed, set the start and acceleration to 150. We won't touch any other wobbler modes here. Next, we press F1 while setting up one Igor. Place it under the keyboard. Let's say it's the top 3 keys there. Let's take the very edge. Select the second Igor and set it up for the second key as well, but we'll have to make it a bit smaller. We're physically running out of keyboard space. There. And finally, one more time here to make sure everything lines up. Yeah, it fits. Moving over to the keyboard. Setting it up now. Well, let's even try this option, just for fun, hypothetically. While we have the chance right now, let's go ahead and hit almost every single key with this text, just to make sure that the focus and the engraving both work correctly and consistently across the entire focal range of the device. We'll be checking each key carefully so we can see how the focus and engraving respond at different points, ensuring everything functions as expected throughout the whole process. We'll do a couple of repeats, no more. Okay, F1. And we'll check the engraving quality. People often ask if the focus can handle height differences. Well, in this case, we'll check exactly that. One more Control-C, Control-V. Got it? Again, I'm visually tracking every move on the keyboard. Right now, we're just tracking the boxes. When I do the same with the letters we're hitting on the keyboard, so we consider the first and most important factor, which is the outline of the letters. For letters like ts and shch, their tails will be lower than the letter's main outline. This is to avoid any future disagreements with the client. You need to align them by the bottom edge. For example, she and shch have the same base, but sh's tail will appear slightly lower. So the outline will be lower, but you actually need to engrave it properly, level with the edges. Okay, so F1 again, and next. Control-C, Control-V. So, for keyboard engraving, it's enough, well, again, for those designed for engraving with backlighting or with white keys painted black, you can use 20LP. If we're talking about engraving keyboards that are, let's say, a bit more complex or tricky or already made of a specific type of plastic, then it's definitely better to use machines from the MOPA M7 series or UV lasers. With UV lasers, it's harder to get the settings right and apply decent settings, but they do a good job on difficult plastics. Okay, Control-C, Control-V, because on a UV laser you can, for example, work on those same PVC keys on the new MacBooks. Well, basically we're ready, so let's quickly select all our letters, the Igor letters or the Igor text, and move to the engraving area. So pressing F1 only gives us a solid line from edge to edge, which tells us absolutely nothing. Let's set it to show outline, and this will be too complicated because we don't just have one letter, but a set of 4 letters. Right, so they'll be displayed like this. Well, basically, you can see visually that everything is falling into place. We did 3 passes, or 3 repetitions, and we press it. Again, just so you don't think I changed or swapped anything here, the keyboard size, well, roughly speaking, from edge to edge, it's going to be 27 centimeters, or 270 millimeters. This is very rarely engraved anywhere. So if I show you quickly, first, like this, we calculate the number of letters accordingly. Everything here is white, everything is legible, everything looks good. Let's zoom in. X3. Look closely. At the bottom, we have the original, and at the top, the letter. Well, let's say, hypothetically, a word, let's treat it as a letter, as a symbol. So the same thing applies here. Again, don't forget the letters that were factory made and the ones we made here. Everything is the same, a perfect match. Now for some simple math, the time spent on 3 passes was 13 seconds. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 times 4 gives us, roughly speaking, 60 characters. 60 characters applied in 13 seconds, well, let's say 15 seconds. Is it convenient or not? How much does it cost? Well, you also have to understand that if we're setting it up manually, it's a tedious process. Takes about 10 minutes. If we use a template, meaning a template where you place your laptop in the center of some fixed workspace, you just press F1, F2, let's say repeat the process F1, hit the bottom part. And let's say, hypothetically, we have everything set up already. There. There's a high probability we'll hit the aluminum somewhere, so one should have done it without rushing, of course. to test it, but there's a chance I'll hit the aluminum after all. I'm worried. And we press, accordingly, 3 passes on F2. More or less hit the same zones, but again, more or less, because the keys are offset, there was a big chance we'd hit the aluminum. So 15 seconds for keyboard engraving. How much to charge for this? Well, masters charge on average 1500 rubles, some charge 3000, some charge 300. For mass engraving, if it's the same laptops, I'd charge at least 300 rubles. The difficulty is in unpacking these laptops. No machine setup with such a load on the equipment. Well, let's say there will be practically no wear, so you can engrave such keyboards. Well, I think the machine will work for 20,000 hours for sure. Because in this case, 20% power is nothing, especially since we're working in the nominal frequency range. So, as always, a thumbs up from you. For equipment purchase options, I'll leave all the phone numbers in the description. Educational material, courses on working with this equipment under EasyCAD 2.0, I'll also leave the phone number in the description. Write on WhatsApp, or in the future, again, I'll leave phone numbers for the Max Messenger. That's it. Good luck and money to everyone, and bye bye.